After 2, 3, maybe 4 iterations, I finally have the wiring situation the way I want it back here. I should have planned it out better. This side has got the ELT and tail light stuff going on here, and this side has the pitch trim and autopilot servo connectors. So now that that's done, I need to make wires that run up to the panel. So let's do that. I don't know if I want to use the red one. Why don't I want to? Because this is the power line that should go directly to the vertical power. And that has a pin already crimped on it. Let me find it. So what I mean by that is that the wiring that they provide you when you buy the vertical power system, for all the power lines that you're running out of the box, they give you wires. Oh, well, they don't give you. Okay, you can buy a wiring kit, or you can buy a crimper for some insane amount of money. I just bought the kit because it came with enough wire to do the entire plane, all the power connectors, or the connections. And so the downside of that is that you have to use their wire. So it's like I'm sitting here building a connector, and I'm building the wiring harness for this connector, and I got to find the specific wire that I want to use, and then I've got to cut it to size for this run before I crimp an end on it that it's going to go into this connector. Not a big deal. I already knew where the vertical power was going to be. I just had to run the line from the front of the plane down through the channels and the fuselage to get a good idea of the length. The good thing is that also gave me an idea of the length for the other wires, even though most of them ended up unterminated at the panel from this run. I'm going from the back of the plane forward in this whole situation, and because of that, I can just run, as these things were put together in the back, I can just run unterminated ends up to the front and then route them as appropriate to where the new, where the receiving component is going to be. These wires that I'm crimping right now are the pitch trim wires. So there's 5 of those, 2 for the power that goes either way, and then 3 for the sensing of the position of the pitch trim. This is the ground wire for this connection. I use black 20 gauge grounds everywhere that I could. And then the yellow wire is commonly used as I followed that common standard or common scheme, I guess, for autopilot disconnect. So that's 1, 2, 3, 4, 5. And I had to go back to my spreadsheet for positioning pins. I started with the Google Sheet to document the interconnects of all these different pins. But I later decided to switch it out for giving actual diagrams, which I create in a program called WireViz, which is a free open source Python script. This is the specialized Gigaflight wire, 120 ohm CAN bus wiring, or whatever we're going to call it. It's a bit more of a pain in the butt to work with because it's got some extra stuff going on in it. I just figure, it's a couple extra bucks. It's a big deal to just not use it, right? So it's just got this for all of the CAN bus throughout the entire plane. The sheathing is thick. The do you want to call this? The sheath is actually a little bit thicker, and then the shielding is as well. It's like a, I don't know what you want to call the shield. It's kind of interesting. It's not just a standard like braid. It's like braided tape almost. It's definitely, like I said, more of a pain in the butt to work with. And then inside, we'll see that in a second, there's additional stuff. They've got these like PTFE wire, or like lines that run through there to keep the wires separated. They're twisted all together. There we go. Here we go. One last little bit to get undone here. There we go. So, first of all, like I said, braided tape instead of just like braided steel wire or whatever you want to call it. Now it's got this PTFE like plumber's tape stuff surrounding it. Then inside of here, each one is like individually wrapped. Let's see. So it looks like you got four wires, but you actually don't. You've got your white and blue, so high and low, and then you've got these two extra plastic pieces in here that they put in as a, like, that's what I'm saying, keep the wires all separated. So yeah, that's your Gigaflight wire that costs a ridiculous amount per foot compared to 22750 or whatever that other stuff is called.
I think Garmin says if you use the Gigaflight, you get an extra 20 feet of CAN bus in their situation. I wasn't anywhere near the limit, but I decided it was worthwhile to try it out. Oh, that was loud. And in most situations, you know, you leave that shield line longer, but this is again going into a connector where it's joining the shields of the two pieces. It's not going to the back shell of a connector. I believe later on I'm gonna say that it like doesn't terminate. It actually will. It connects it's going to connect the back shell of every single CAN bus device in the entire network.
Okay. So I'm going to use my spreadsheet that I created that tells me which wires go where, and that way I know. That's how I knew which ones to go in here. I'm going to follow up later once I get the other side of the harness in position with where the power wire is going to come from the VPX to this. But these are pretty easy because then we go pin 4 is CAN high, so that's white. Here's from pin 4. CAN low is blue, and the sheath is on pin 6. So we're going to carry that sheath through. That's grounded at the servo. And then the other end of this will not be grounded. We'll just leave it dangle. So that way you have one end of the line grounded. You don't create a separate path to ground for something. So that's that.